The effects of a titanium dioxide catalyst on the photocatalytic treatment of polluted wastewater. In the world today, there is an increasing demand and shortage of clean water sources. Untreated industrial wastewater can contain inorganic and organic pollutants including aluminum, copper, and arsenic that can be carcinogenic if they get into our sources of drinking water. As the global population continues to increase, the demand for clean water will increase while the supply of clean water will not be large enough, especially in developing nations. In addition, several water treatment plants do not have the necessary protocols and treatment facilities in order to clean the water. Photocatalytic treatment involves the use of ultraviolet radiation to cause a chemical reaction to break down the contaminants in water. Titanium dioxide can speed up this reaction by breaking down the chemicals in the water and making it easier for the photocatalytic treatment to occur. Titanium dioxide 4-brookite is the most effective catalyst for the purification process due to its safety and because of the larger surface area that it possesses and the faster reactions that can occur. The titanium dioxide has the greatest effect under light of 300 nanometers to 390 nanometers because at this light it remains stable and it continues to have the same effect after repeated catalytic cycles. A method of examining the amount of organic contaminants in water sources is measuring the chemical oxygen demand, as it shows how many pollutants the chemicals have removed. The use of many chemical treatment methods involving titanium dioxide have been found to decrease the chemical oxygen demand, and it will also decrease the amount of organic pollutants in the water. When a titanium dioxide molecule is struck by a photon, it releases a free electron, and this electron causes a series of oxidative chain reductive reactions, which results in the destruction of the contaminant into smaller molecules that can be easily broken down by the UV radiation. Titanium dioxide can catalyze a number of photocatalytic reactions, including reactions with organic contaminants such as bacteria and reactions with heavy metals including copper sulfate and arsenic. During the photocatalytic reactions, harmful materials such as formaldehyde are produced. However, they undergo photocatalytic reactions as well under the UV radiation, and they are reduced to carbon dioxide and water in these reactions. This animation shows the effect of titanium dioxide brookite on the reaction. The catalyst enables oxygen and hydroxide molecules to bind with valence electrons, and then these free compounds react under exposure to photons to form water and carbon dioxide. In Chong et al. 2010, various chemicals were used in the development of photocatalytic methods to reduce contamination in water. A multitude of variables are used to determine the optimum photocatalytic efficiency, and the photocatalytic water treatment processes were found to be a viable option for waste treatment. TiO2 was found to be the best catalyst for water treatment before the photocatalytic processes were used, and the series of oxidative reduction reactions made it possible for the catalyst to be effective. In Mulatto et al. 2002, various methods for photocatalytic reactions were examined and completed. Different treatment methods for other types of water treatment reactions were also looked at, and it was shown how these reactions are not effective compared to the photocatalytic reactions used in this experiment. Different tanks containing titanium dioxide and the contaminated water were set up in this experiment, and valves containing the contaminated water were transported to the titanium dioxide for treatment. This provides methods and bases for future experimentation and exploration in this topic, as well as the filtration of the titanium dioxide after the treatment in order to ensure that the water quality is drinkable. In the study by Asbar et al., the effect of pH was examined on the chemical oxygen demand removal in the water, or the effect that pH had on decreasing the amount of contaminants in the water. It was found that higher pH values resulted in a faster photocatalytic reaction and more removal of the contaminants in the water sources. The purpose of this study is to break down inorganic and organic contaminants in water with photocatalytic treatment and result with clean sources of water. Based on the studies of Chong et al. And Mulatto et al., the addition of a catalyst of titanium dioxide to contaminated water during photocatalytic processes will result in higher rates of degradation of inorganic and organic pollutants. Part 1 of the method will involve calculating the optimum wavelength values for the contaminated solutions using the spectrophotometer. A Beer's law plot will be determined using this data and it will be based on the absorbance readings and the spectrophotometer. In part 2, two different solutions of chemicals will be prepared to simulate pollution in the environment: aluminum sulfate and copper 2 acetate monohydrate. The first group of chemicals will not have titanium dioxide for Burkett treatment, and the second group will. One group will have 25 grams of titanium dioxide and one group will have 50 grams. Both of these solutions will be thoroughly mixed in with the titanium dioxide. The solutions will be exposed to UV radiation for 5 hours for all groups and then rested for 30 minutes before being analyzed on the spectrophotometer. Data will be taken on the spectrophotometer and the values of absorbance measured using the optimum wavelength value from absorbance from part 1 will be used to graph this data. This is my budget, and this is my bibliography.